So, I'm Erez from Sky. You might know us by a previous name, Kenshu. I'm VP Platform, and I've been leading the data organization of Sky in the last 5 years or so. We're building a full circle marketing platform and serving some of the largest companies out there. And as such, data is a key aspect of our strategy. Actually, producing value out of data is a key aspect of our strategy and part of my day-to-day work. And over the years, there was one issue that has been bugging me, is how do we break the monolith of data, right? Because in order to generate value out of data, you usually need to join multiple data sets, and only when those data sets are running together, you're able to produce the insights or whatever you're expected to deliver. And by joining multiple data sets together, you usually just create a monolith. You have a centralized team that owns this aspect in the company. And over time, you start seeing the impacts of a monolith. You start slowing down, cycles are slower, weird issues start happening. We've seen this in the software industry, and this was solved by the revolution of microservices and feature teams and so on. And I kept asking myself, where are those feature teams of data? How do we find the microservices of data? And I came back to this question throughout the years, and at some point in one of the lockdowns of 2020, I've been Googling and trying to find references, and I stumbled upon this article. The title seemed promising, right? How do we move beyond the monolithic data lake to a distributed data mesh? It kind of had all the keywords that I was looking for, and I started reading. A few minutes into the article, I was amazed by two things, mostly. One, this is a very long article. It's not your usual 3 minutes read on Medium that you usually find when you're Googling something. It's really more of an almost academic paper. And you need to focus and dive into it, to fully understand what's going on there. But the second thing that struck me was that it described exactly the issues that I was experiencing, and it described a prescription or a paradigm of how to distribute this data monolith, exactly the kind of solutions that I was searching for. And it's not only me that found this interesting. So people started talking about it, blogging about it, mentioning it. There's also a hashtag on Twitter for data mesh, and all kinds of companies and infrastructure vendors are posting about it. And lastly, there is an O'Reilly book just recently published, which kind of sealed the thing that data mesh is a real thing and you should probably be aware of it. The true hero, or the star of the data mesh world, is Zhamak Dehghani. She's the one that published this article that we've seen before. And before 2019, before publishing this article, she was a consultant on ThoughtWorks, not a very famous one. But after the article was published and the hype grew, Zhamak became a well-known persona and actually added the data mesh founder title to her LinkedIn profile. So why should you care about data meshes? Any one of you probably have a centralized data repository in your company. It might be a data warehouse. I hope not, because those are kind of old technologies. They were replaced by the data lakes that brought us schema on read and distributed systems. But data lakes turned into data swamp rather quickly. And in the last few years, we've seen the data lake houses, which are magnificent beasts of serverless and managed solutions that do bring the promise of infinite scalability, as long as you have your credit card with you. But one factor remained a bottleneck, and this is the human factor. Just keeping up with the data change rate is becoming more and more complicated and more challenging. The data is growing, we know that for ages, but it's not only growing in volumes. It is growing in complexity. The meaning of the data keeps changing. New attributes are added to APIs. Database tables get frequently updated, and having a centralized team that needs to keep up with all of this and understand the true meaning of each and every change and propagate this change to the relevant pipelines and dashboards and ML models and whatever you have in your company is just becoming too hard. You cannot follow and keep up with this rate of changes with a centralized team. And this is exactly what a data mesh is about. So what is a data mesh? There are 4 principles to a data mesh. One is domain ownership. The data of your domain is owned by the domain owners, the one that actually know the data best. They know the APIs. They know what it means. They own the data representation of it. We treat data as a product, not just a byproduct. It's a key factor of the value that we deliver. Everything needs to run on a self-serve infrastructure because managing data is complicated, and we want the domain owners to focus on their domains and not about all the pipelines and wiring of things. And it needs to run on federated computational or governance, which is a big term for saying you need to be able to query it at once, right? You need to have a single entry point where you can run a query and get to all of your data. So let's dive right in and try to build one. We'll look at 4 sections. First, how we create our first domain. How do we create inter-domain relationships and actually make a mesh out of a set of domains? What is the role of the platform in all of this, and what does data as a product actually means? And we'll start with an example. Let's assume that I'm working in a company that builds a media player, a streamer. You probably know 1 or 2 companies that does that. And I'm on the team that actually manages the playlist service. Okay, so I own the playlist domain. I usually have some API for the functionality that we provide for playlists, adding songs, removing, creating, all that. Here is an example REST API. And behind this API, there's probably an implementation, which might look like this. If I want to play a playlist, I want to load the relevant playlist information from somewhere. I probably want to increment some statistics to make sure that we know that it's been played. And finally, I need to find the actual media files wherever they are located and stream them to my audience. This is a pretty standard description of the software domain. No surprise here for anyone, I hope. If we look deeper on the data aspects of this domain, then a probable implementation would be storing the playlist metadata in some relational database. I might keep my counters and statistics in a document or a key value database. And there's probably some dedicated storage devices or arrays that have the actual media files on them. Now, if someone is trying to answer one of those questions, right, trying to understand what is the ideal number of songs per genre, or just trying to do some capacity planning on what is the expected growth of volumes that I need, those are questions that are really hard to answer if I only have the APIs of my microservice. But the data that supports them is available in the system that we just described. So what if the team that owns the playlists domain would generate a big JSON file with an array of all playlists? They'll put in the playlist metadata as attributes in it, and they'll include data from the various songs in the playlist and enrich it with all the statistics for my key value database. And just have one big file, put it, let's say, on S3 in a well-known location that everyone can access and read. Having this would be very valuable to anyone who's trying to answer something which is not exposed through my application API. This is our data domain. Okay, so it kind of resembles what we know about software domains, but decouples the data aspects from the implementation details of the application and expose this data for anyone who might need it outside of the context of how we use it to serve our clients. Like any software domain, we have 2 parts. We have the contract, the API. This is the file, the schema, the frequency of update, right? And we have the implementation details, which is all the work done behind the scenes to gather the data from the various storage systems, transform it, clean it, and put it in this file. Obviously, the users only know the API, and all the implementation details are behind the scenes and are abstracted away from the potential users of this domain. if you look at a real-life example, at Sky, what we do, we store our domains or our entire mesh on Snowflake because we find it very valuable for consumers to use it from. Each domain is represented as two schemas. We have the public schema, which is kind of this big JSON file, which everyone can use and query the data from. We have private schema, which is the implementation details, where all the pipelines and temporary tables are being stored. Usually, the public schema is modeled as a star schema, and most often orchestration is done with Airflow, but we have many other tools if someone chooses to use them. Great. So we have our first data domain. Now let's look what it means to make a mesh out of it. So apparently another team in our organization also read this article and decided to create their own domain, and this is the users team. They made some valid technical decisions, but those decisions are kind of different than what the playlist team did. They decided to model their data domain as a table on Snowflake. This is how it looks like. Anyone can spot issues here? Think about problems? Well, many of you probably noticed that data is stored on different storage engines, and there's no single query engine that can join data from those two domains, which is an issue. Obviously, you can do it. You can import this way or another in any direction, but this puts in additional effort on the consumers of the data and requires additional understanding and effort on their behalf. But even if I was able to import the data into a single query engine where I can query all together, I'll find some additional issues. For example, look at how users are represented. Previously, users were identified by their username. Here, users are identified by their emails. Okay, trying to identify the same user across two domains is kind of an issue. Look at the language. Here we have a standard locale. Over there, we had the language name. So trying to make sense out of this data is complicated, and even if I've solved this, good luck with trying to merge the last month with the last 28 days, right? This won't work, and it is becoming more and more complicated for our consumers to make sense out of those two domains. So it's not a mesh right now. What makes a set of domains a mesh is unification. Unification gives us domain interoperability, and with this interoperability, we have the physical layer, right, having everywhere under a single query engine, but we also have the logical layer, which defines the standard granularity that we should look at data and the standard dimensions that everyone should be using. The counter really moved fast forward right now, so I'll speed up my talking. So under this unification assumptions, we can actually use multiple domains and combine them into what we look at as a mesh. Another aspect of a mesh is data reliability. We just had a talk about it a few minutes ago. Being able to rely on this data, on the information, make it trustworthy is a key aspect, and moving it to distributed system makes this more challenging, right? The data downtime is a new term that was coined into the point where we should be able to make sure that our entire mesh is functional and keeps integrity at all times so clients can always use it and consume data out of it. What we do at Sky, on top of all the pre-production tests, we're actually running in-production validations kind of in a Git-like style, again, as we saw before, where each pipeline, which usually is composed from ingestion, processing, and publishing sections, we add validations. One is post-ingestion validation, where we check that all the data that we got actually meet our expectations and meet the contract of whoever is publishing this data. Next, after our processing, we are validating that we are actually going to match our own contract, and we're not going to add garbage into the entire mesh, making the data not trustworthy as we want it to be. Only if those two checks pass, we continue and publish it to the public schemas where everyone can use it. So the mesh is actually becoming useful and more popular in a company, and we have the team that owns recommendation systems, and they're happily consuming data from the users and from the playlist domain, and they're running their magic and ML models and whatever, and they're producing data recommendations per user, and since they are happy clients of the mesh, they actually publish their data as well as a new domain, but that's not the point. just before they run their machine learning algos, they need to do some heavy lifting of processing, of joining the data from those two domains. While it's not super complex in terms of logic, it is heavy lifting in terms of scale and performance, and running this over and over again becomes tedious. So what they've decided is to save the data just before they run their models and processes on, in a way that is easily consumed by their systems. We see here another type of domain. If previously, the two domains that we saw earlier, the users and the playlist domains, both of those domains highly resembled some source system that we were reflecting. Those are called by Zhamak as source-oriented domains. This new user similarity domain is highly resembling the system that is going to actually consume the data. And this is called a consumer-oriented domain. If we look at a larger example, and this is how we look at things at Sky, we can arrange our domains on some two-dimensional landscape, where one axis is whether this domain is more towards a source system, representation of a source system, or is it modeled in a way that's easy to consume by some consumer application. And this is a range, it's not a 1 and 0 thing. The other axis is whether the data in this domain is more towards serving our clients and our product functionality, like, for example, user recommendations or suggestions, or is it a domain that is more oriented towards serving the internal company for our own employees to make smart decisions on. So this is what a potential domain map can look like. So congratulations, we now have multiple domains, and those domains are talking with each other in the same language. Let's move on to the role of the data platform. Actually, the task of the platform is to remove all the friction that is needed in order to create those domains. Right? We talked about domains being owned by teams that are highly experienced with the knowledge about their business, of what they are running. But those teams are not necessarily experts in managing data, in setting up pipelines and all the aspects of managing high-scale data. Just look at the number of tools that one needs to know, and those are the tools that we use at Sky. You need to set up your DAGs, you need Git repositories, you need validations and checks. We use Great Expectations here. You need to understand and know how to set up things in Snowflake and monitor costs, and there's a bunch of things that you need to do just to get started. At Sky, we've created a single command line tool that within a hit of a click of a keyboard button, you can set up and scaffold everything. So you can go on and get to the details, to the content of what you're actually doing, right? If I'm a domain owner, I want to get done with this setup part and later in the future not be concerned and bothered by the maintenance aspects and focus on the actual content and the value that I can deliver. Another aspect that the platform is about is setting the standards. How do you represent currencies? What are the standard dimensions? How do you give catalog capabilities, security? There are a lot of things that need to be standardized for the mesh to be a mesh. You can look at the platform sort of as if it is the government of the mesh. What the government usually does is providing the infrastructure, it builds the roads and the bridges and schools, and sets the rules that everyone needs to play by. But, like any other government, we should make sure that the government knows that it's here to serve the people, right, and not the other way around. A common pitfall is for the platform to become obsessed with control and forgetting its true purpose. And for that, the management of the company need to set the proper KPIs that would guide the platform teams into making sure that they are providing the value to their clients, to the producers and to the consumers. Metrics about data uptime, metrics about how fast is it, to set up your new domain, the number of domains that you have, whatever you think would accurately represent the fact that your clients, the platform clients, are getting what they're expected to get from the platform. So we have all the technicalities in place. Now we have this vague term of data as a product. What does this mean? This is a key aspect of the data mesh concept, and it's not a technical concern. This is a way of thinking. Right, let's look again at an example. Now we have our own mesh, and the songs domain needs to be represented by the songs team. And they thought, okay, that's great. I'll just collect all of the songs that I have, put in the singer and the author and the length and all the information I have about a song. Just put it out there as part of my domain. But let's take a deeper look. Look at this song, Hallelujah. Are all those the same song or not? Having the same song by different performing artists should be considered as one or two. If I have multiple versions of the same song, a live audience performance or a studio recording, is it the same? This is really a product question. What does our consumers need? Are they looking at finding the longest song, the one with the longest duration? In this case, I might want to keep them separate. Are they looking for the most popular song with the highest recordings or the highest occurrences? Those have very different answers, and this is exactly the work of the product here. They need to understand what is the value expected from the consumers and model and design your data in order to solve for that. You can think about the example of bottled water, right? In a company that sells bottled water, the water is a product, the bottle is a byproduct. You need it, but you don't put a lot of thought around it. And then there's another cycle. There's another company that collects these bottles and may be able to generate value out of those. But those are two different cycles. When you think about data as a product, it means that the cycle of generating value out of your application and generating value out of your data is the same cycle. Those are the same owners. It is the same value chain and not a separate one. When you do that, you start asking yourself, who is the user? What is the value that they are expecting to get from my domain? And once you do that, the rest is easy. You have like 80% of the work done here. And now you need to go into the details of setting priorities, defining the MVP, specifications. You can measure usability and adoption of your data, just like you do with any other product, just to get a feedback loop and understand if you're in the right direction. So this is what it means to do data as a product. And once looking on it this way, you understand that you don't need really any high technical skills in order to be a data product. It's just doing product work when your value is coming from something which is not your application. I hope everyone are convinced by now that a mesh is good for you. Now I want to take a step back, zoom out and tell you about all the things that you didn't hear about and you won't find easily. I'll start with saying data mesh is a new concept. It's not mature. There are different variants of it. There is no single prescription that one should follow in order to create a successful mesh. Yes, we have all the technicalities. Yes, we have some guidelines. But if you're going to go this route, you're going to follow some unpaved roads and you need to find your own way. And I want to highlight just 3 out of those aspects, again, from our journey in implementing a mesh. Is there anyone that doesn't have a unified data repository in their company, in the audience right now? There might be a few, but I guess that most of us don't start with a greenfield. Most of us already have some centralized repository. And moving into a mesh actually means a transformation. And doing this transformation is hard. The good thing about transforming a monolith into a distributed form is that it's already been done before, and the same best practices apply, right? The same way as you distribute an applicative monolith, doing it with a data repository is kind of the same. It's going to be a specific route, but what you need to do is take it one step at a time. You start with the easy parts. Maybe you don't start with distributing everything, but find a new domain that you can build outside of your monolith. Demonstrate some value out of it, build another 2 or 3 like this, gain confidence in the fact that you're doing the right thing and you're taking the right decisions. And once you demonstrate this value, you can move on to the next step. Maybe then you can try to take a bite and take a chunk off of your existing monolith. And again, as you go, you do baby steps, you demonstrate value in each and every step, and then you expand, you gain the momentum, and you continue up to the point that you feel that you got to a position which is convenient. It might well be that you'd still have some of your data in your monolith, and that's okay. If you got to a position where the value is streaming in a way that doesn't stop your business, there's no strict guideline that says you have to distribute everything. So that's one aspect of moving into a data mesh. Second thing, I want to talk a little bit about mesh economics. I think this is the biggest pitfall and the hardest part that I've encountered so far. Think about it. When you're looking into building a mesh, the one that would greatly benefit from it, the one that would gain the highest value, are the consumers, right? They're gaining access to data, which was very hard for them to get hold of. But the ones that are actually doing all of the work and investing in it are usually the producers, right? Those are the ones that we just talked about, all the effort that they need to do in order to build their domains. Now, there's value on one side and there's cost on the other side. And if someone's not balancing it, it's not going to work. There's just no incentive for domain owners to build new domains. They already have this data. They know how to access it. They don't really need it. This is where the government or the company needs to come in and set the right economic model that would encourage people to do the right thing. They can make sure that the platform is doing their job to reduce the cost of building a domain and making it a less hard choice for the domain owners. You can have loans, maybe from your platform team. We have great data engineers and data experts in our own data platform teams at Sky, and we attach those to projects where we think that setting up a new domain would be valuable within the scope of this project, and by adding resources as a loan, we can make sure that the project timelines won't be delayed, making it an easier decision for those who need to make it. So think about all kinds of economic models that would allow people to make the right decision. This is your goal. I think that the holy grail is reducing the cost of generating domains and operating in a data mesh to the fact that it's actually the easy choice. It is what people would intuitively do. And if someone wants to consume data, even their own data, they would build a domain just to consume it as consumers as well. And if you reach this point, then you can safely say that you're operating as a data mesh company. And last but not least, I think that in every talk that I gave in the I don't know, last 10 years probably, Conway law. If someone still haven't heard about Malvin Conway, the guy said that the architectures that companies would produce would resemble the organizational structure of those companies. And more importantly, if you are aiming towards an architecture that you want to have, maybe you should start with structuring your organization in a way that would resemble it. This is the inverse Conway maneuver. So if you want to go into a monolith, into a distributed data mesh architecture, but you still have a monolithic or a centralized data team that owns everything, after a few domains and after a few months, weeks, you start feeling the conflict, you start seeing the friction. And this might be a good time to rethink about your organizational structure and maybe reflect this in a way that is more appropriate towards generating a data mesh. So, if I got your attention, here are some links into additional reference material. Obviously, you have the original article, which I encourage everyone to read. There's also a recorded video on YouTube for those that reading is too hard for them to do. You can Google it, you'll find it on Twitter, just look around, you'll find many, many, many references. The buzz is high and you'll find a lot of good material about it. But I think the biggest advice that I can give you, just go ahead and start. Try it, do it small, do it baby steps, learn in each and every step that you do, and would love to hear back from your experiences. Thank you.